Good morning, class. Today we're going to see a couple of new subjects. Now, today's class as individual portions are quite simple, but there's a couple of things that we have to go over today. Now, we're going to go over 9.2, which deals mostly with standard precision radians, converting degrees to radians and vice versa, sector area, and arc length. So first, when we look at page 470, the first thing we see is angles in standard position. Now what this means is two things. First of all, the vertex of the angle will be on the origin of a coordinate axis, and also the initial part of the angle will always be the right side of the x-axis. So this is where I begin. Now note that positive angles go counterclockwise and negative angles go clockwise. I use this figure to remind myself. If I begin horizontally, positive, just think up. So I begin horizontal and I go in a positive fashion. Negative, I begin horizontal and I go down. Note that a positive angle could end up pointing downward. That's fine. Again, positive or negative only relates to the direction of the rotation, not where I end pointing towards. So for example, if I go positive 270 degrees, I would begin here, think that this is my end. So let's go like this, actually better. So I go 90, 180, 270. So I would end up pointing downward, but that doesn't matter. Because remember, the positive only relates to rotation. Also, I could go negative 90 degrees. I begin horizontally and I go down negative 90 degrees. And this brings us to our second part, which is coterminal angles. Two different angles that end up exactly at the same place. Now there's a couple of ways to end up with coterminal angles. The easiest way is to just add an extra circle or subtract an extra circle. Again, if you're looking at a particular point and you do a rotation clockwise, you're going to end up looking at the exact same spot. You can do a rotation counterclockwise and you will look at the exact same spot. So for example, if I have an angle of 20 degrees, would be maybe something like this. If I add a circle to that or an entire rotation, I'm going to end up with positive 380 degrees. So let's see if it's true. I go 360 and then 20 more, I'm going to end up at the exact same angle. That's a coterminal angle. At the same, in the same situation, you could subtract 360 from 20. If you subtract a circle, you end up with negative 340. And if you realize it, starting from the initial position, negative 340 is almost a complete circle, but I would be missing 20 to do a full rotation. And I would end at the exact same spot as this angle. They are coterminal angles. The definition of coterminal angles are angles who have the exact same terminal side. The initial side is the right side of the x-axis. The terminal side is the side that actually moves up or down, rotation-wise. So that right there is the example 1 and example 2. Now here's the new subject I don't think you guys have seen. It's about radians. Now, even though we're gonna get into the definition of radians a little bit, deeper next year, just think that, degree is only a measure of, it's only an angle measure. You don't know how far away the person moved. You don't know anything else except the degree, the opening. Now, radians are a mix of angle and length, so it gives you slightly more information, so it's more precise in a sense. So even though we're going to get into that deeper later, just know that radians give you the extra benefit that it's a relationship between an angle and a side length, so to speak. But the basics of radians are, in one circle or one rotation, there will always be 2 pi r radians. You can just say 2 pi radians, pretty much. Denme un segundito. Okay, just say 2 pi radians in a circumference. One thing to keep in mind, just like there are 2 pi radians, there are also 360 degrees. So 2 pi radians equals 360 degrees. So in order to convert from radians to degrees, there is a very simple measurement, or rule of 3. If we divide this by half, I'm left at 1 pi radian equals 180 degrees. Now note that just like you can divide a circle into 180 degrees and 90 degrees, 0 to 70, you can also break it down into radians. 0 pi radians, half of it would be 1 pi radian, and just write radians, not r, because just say radians. 0 pi radians. Up here, it would be half a radian, so it'd be pi over 2 radians. Here, even though it's kind of difficult to see, but that's 3/4 of the circle, so it would be 3 pi over 4 radians. And you'll see why that's important a little bit later. But right now, in order to convert, know that 1 pi equals 180 degrees, and that just like you can break up the circle into different degree measurements, we can also break up the circle into different radian measurements. Now, when we're going to convert radians to degrees or vice versa, there's a very simple method. Say, for example, they give you 70 degrees. We know that 1 pi radian equals 180 degrees. So all you have to do is equal that to you multiply it. I'm a little slow. Sorry about that. I'm sick and tired of being at home. But so we have 70 degrees. All you have to do is multiply that by the ratio. So you always want the value or the unit that they give you. If they began giving you 70 degrees and they want you to turn it into radians, you put the exact same unit at the bottom. And I know that 180 degrees equals pi radians. Same time, if they give you 3 pi radians, again, we're going to put the initial unit they give us at the bottom, pi. And I know that 1 pi equals 180 degrees. Why do you always put the same unit they give you at the bottom? Because you'll see when you go into physics, you cancel out the units just like if they were variables. So centimeter cancels out centimeters, just like x cancels out x. So I cancel the degrees and I'm only left with the radian unit. Likewise, here, I would cancel out pi radians, and I'll be left with the degree unit. So the unit they give you to convert will always be placed at the bottom of a ratio that forms the conversion rate of the units. All you have to do now is calculator. One thing to note, don't convert this into 3.14, blah, 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 blah. Just leave it expressed as pi. So all you gotta do is divide your 70 by your 80. Again, I simplify as much as possible. 7 over 18 pi, and that would be the answer. Or you could divide 7 by 18 and put that decimal next to the pi, like 0.2 pi. But always leave the pi there. Do not multiply by 3.14. Here, again, very simple. Simplify, get rid of the pi radians. 3 times 180 equals 540 degrees. Done. All that's everything that's required to convert. But you do have to remember that 1 pi equals 180 degrees. And then either the pi goes at the bottom or the 180 degrees goes at the bottom. depending on what they give you to convert. Pretty straightforward. Now let's go over. We went over the conversions. Let's go over arc length and sector area. These are two new definitions, or you might have seen them. Actually, I think you saw them in geometry, but let's just review the formulas. S equals R theta, and A equals 1/2 R squared theta. One thing to keep in mind, whenever you're dealing with arc length and area of a sector, theta, theta measured in radians uses this particular formula. So let's say, for example, they say a circle has a radius of 3, okay? And the portion of the sector is formed by an angle of pi over 2 radians. Just in case, again, circle, the arc length would be just this part of the circumference. A section of the circumference is an arc length, and the sector area, this part of a circle would be a sector, and the area would be the entire thing. So let's do both for this particular circle. Now I know that my arc length is radius times the angle measured in radians. I am given the angle measured in radians, pi over 2. So the arc length would literally be 3 pi over 2. Or if you simplify this, arc length would be 1.5 pi. Either of them are correct. What you cannot do is convert this into 3.14 and continue. But either one would be perfectly fine in an exam. That takes care of arc length. Now let's go over area. And again, this example was easy because they gave me an example in radians. Let's go over the exact same exercise, only for area now. And I know that the angle was pi over 2. Now let's go over into area. Area equals 1/2 radius squared, 3 squared is 9, times pi over 2, which is the angle measurement. So now again, we multiply all the numerators. 1 times 9 times pi gives me 9 pi. Multiply all the denominators. I have 1 here. Gives me 4. Again, you can leave it just like that or divide in your calculator. 2.25. You can either have that or 2.25 pi radians. Perfect. Now again, that was simple because they gave me the angle measured in radians. Now let's say they give me degrees. Angle they give you is 180 degrees. Let's change the radius as well. Now, first, all we have to do is just convert. And again, this is a very simple conversion. Usually, the exam is not going to be that simple. They're going to give you, crazy numbers, 70 degrees or something. But again, I don't have a calculator right now, except my brain. So, gotta use easy numbers. So again, we're going to convert 180 degrees. Again, the unit they give me goes at the bottom because 1 pi equals 180 degrees. This cancels this, multiplying. This simplifies this. So an angle of 180 degrees is the exact same thing as pi radians. Remember, don't just say an angle of pi. Pi radians. You always write the word radians. Pi radians. Now all we gotta do is plug these values into these formulas. So again, the arc length would be radius times the angle expressed in radians, which it is. So the arc length would literally be 2 pi, and the area would be 1/2 of the radius squared times the angle measure, and 1/2 of 4 is 2. Whoa. The sector area would be 2 pi radians. Okay. That's pretty much it. Also remember, right now we're using numbers, not units. But area normally should give you like, centimeters squared or something like that. Since we're using straight numbers, there is no unit to square. But normally when we work with area, you're given centimeters, meters, etc., etc. So you can use the proper squared units. That's pretty much it for today's class. Now for homework, please do the following. Please do 5 through 8. That's just a rough sketch of where the angle should end up. But one thing to note, don't just draw the angle. Don't just draw the angle or the terminal side. Please always put a line here and rotate so I know which direction you rotated in. So for example, say I'm given 100, or say I'm given negative 100 degrees. Do not just draw it like this, because I don't know if you went this way or this way. Even though the angle ends up at the exact same spot, when we're drawing these, you always note what direction you're rotating in. So make sure you include that. Again, it doesn't have to be perfect for the examples from 5 through 8, just more or less an approximation or a sketch of the angle and also the rotating, what direction it's rotating in. Please do 9 and 10, which is just finding coterminal angles. And it says here, just find one positive and one negative for each one. So you have to add circles or remove circles until you end up with a positive angle and a negative angle that is coterminal, for example, 9 through 10. Please do 13 and 17, which are just conversions. Again, 5 through 8, 9 through 10, 13 and 17. And please do a word problem, number 28, which has to do with sector length and area of a sector, or arc length and area of a sector. Pretty much that's today's class. Go ahead and upload the homework at the homework forum. Again, we should be ending this subject next week with a test, and then it's project till the end. I might give you 1 or 2 project days next week, and maybe do this final exam. This is the last exam you guys are gonna get. I might make this exam on Monday just to give you guys the weekend to study a little extra. Then it's project all the way till the end. So have a great day, guys. If you have any questions, please let me know. Otherwise, I will see you guys on Monday. Because remember, tomorrow, Friday, you guys have it off. So if you have any questions, let me know. Otherwise, I'll see you guys on Monday. Have a great day.